Okay, back to the gaming. An API gateway for Erlang and Lua. So I'm going to talk about a bit about what we mean by an API gateway and why we felt we needed it. So I'm from UX5. My name is Johan Lo. I'm one of the developers at UX5. We're a small team, 4 persons, founded in 2012 and based here in Stockholm. We focus on building back-end solutions for free-to-play app games. So back-end driven games, we usually call it live operations. So a lot of configuration management, but also multiplayer backend solutions. So we've had a lot of different projects, but the major one is on the left here. It's actually our own game. Typically we don't make our own games, but we just work with game studios. But now we made our own game, and we've been working on it for the last year. And it is in soft launch right now in Indonesia, and this game is the context of the whole talk. It's that's where we actually use this API gateway, and I'm just gonna show you a short trailer here. Okay, so right now it's only in Indonesia. It's looking pretty good. We have 4.8 in rating so far. We're quite happy. And actually, it's kind of funny. I was when I was preparing this talk, I was just focused on the backend side of this API gateway that uses Lua and Erlang. But so I didn't even consider that the entire game is written in Lua. Actually. It uses the Corona SDK game engine, which is, of course, using Lua. And it's about 40,000 lines of Lua code by now, which feels quite a lot. I'm not sure how we ended up there. Well, actually, I do know why. Because Corona doesn't have a good way of creating UIs. So you have to basically write all the UI code yourself, which kind of explodes the code. And Corona was fine. We had some problems, like the UI. We had a bit of problems with the physics engine there, but we worked it out. And then we had some issues with the Lua socket HTTP library, because we wanted to have, well, at first it wasn't a problem. The Lua socket library doesn't support persistent HTTP connections, which was fine when we were testing in beta and so on, because we were testing in Sweden and so on. But then when we shipped to Indonesia, things kind of started to fall apart because the network was so bad. So having to reconnect the TCP connection for every request that we sent to the server just completely killed the performance. So we had to write our own persistent connection on top of the Lua socket library. So most of the game logic runs on the back end. Obviously, you're swinging in the rope and so on. That's done on the client side, but pretty much everything else is done on the back end. And there are a few reasons for this. The main reason was for live operations. We want to be able to, during the lifetime of the game, we want to be able to change things without having to update the client. So if we see that the game is too difficult, then we need to be able to change whatever is making it too difficult without actually having to push out a new update to the client. Player progression, yeah, too difficult. Multiplayer, this is a type of multiplayer where you are playing against recordings. So the other players that you see swinging are recordings that have been taken. So if I'm playing, I reach the goal, then the recording of my gameplay is sent to our server, and then this recording will be matched against someone else who's playing later on. And obviously that needs to be handled by the backend. And then we have the anti-cheat perspective. So we have a large upgrade system. We have virtual coins, diamonds, high scores, etc. And in the beginning, we actually tried to not put everything on the back end, but one of the other developers on the team had experience from an MMO game that he had been working on, and where cheating caused they lost 70% of the revenue because of cheating. So he was very much against keeping anything on the client at all. So let's see. Right, of course. The backend is written in Erlang, completely in Erlang in the beginning. And that became a bit of a problem during the development process. So backend is written in Erlang. Not everyone knows Erlang in our team. And the iteration became that, so on the client side, you wanted to implement some new functionality, you want to try something out. And so you write it on the client side in Lua. And then when you're happy with that, we took that and we ported it to Erlang. And then the client would call the backend to get to perform the function. Obviously, this is not very good if you just want to experiment with stuff or you want to move along quickly, because there's this iteration where you write it in Lua, and then someone of us that knows Erlang have to port it to the Erlang code, and then test it, and then repeat, and so on. So that was our major problem during this project. So I'm going to show you just a quick demo of what we're talking about here. Let's see. So this is the Corona SDK simulator. So I'm going to be talking a bit about this chest system that we have. Well, it's not. Okay, so I have a free chest here. So there we saw that it connected to the server. So it was actually sending a request to the server saying that, okay, this player wants to open this chest. What should I give it to him? So the server then sends back this kind of icon that you see here. The player collects icons, and then they can use that to upgrade their hero to become stronger or faster or whatever. But this part here is very interesting in terms of player progression. What kind of icon should we give to the player? And this is something that you need to do on the back end, because we're not sure that we actually got it right. Maybe it needs to be updated. Maybe it needs to be tweaked somehow. So we can't put that logic on the client. So this is a crucial thing that must be on the back end, and also something that needs to be able to be updated pretty easily, or you need to be able to experiment with different implementations easily. Oh. So here you can just see what the icons are used for. So you can, okay, so you could equip this icon, and this is another call to the backend saying that, okay, the user wants to equip this icon for this hero. And all the user data saying, you know, what kind of inventory you have, how much coins you have, everything like that, which icons that are equipped, that is stored on the server as well, of course, and the client just fetches it from the backend. We'll kill that one and go back to the presentation. So actually, I can show you the code for this one. So this was an early implementation of the chest opening function. You can see that one. So there's a lot of basically randomization here, but it's not completely random, of course. It depends on how far the player has progressed. If maybe he's been away from the game for a long time, and then he should maybe get a nicer icon or more useful icon than before. It's actually, the actual implementation we have today is a lot more complicated than what you see here. But I'll get back to this one later. Okay. So a bit about the back end. So if we look at this one here, you can basically see everything about there. That's not important. So we have something called the API endpoint. It's really a web browser. Oh, sorry, a web server. So in this case, it's called the server is called Cowboy. It's an Erlang web server, and then you have the request handlers. So the HTTP request comes into the endpoint, and then the web server determines which request handler should handle this request, and then you have to route it to this one. And these could be running on well the same machine or different machines, or yeah, you can run it on multiple, of course. And then there's some data backing that up. And all of this was written in Erlang, or actually it still is written in completely in Erlang. So we have this flexibility problem. The iteration process is way too slow. So what can we do about that? Well, we decided that we needed what we call an API gateway, and just a short while after that, Amazon released their own product, which is called an API gateway as well. So I guess we'll say good name, and they have a good definition of what an API gateway does. It's intended to be used to create, publish, maintain, and monitor APIs. And by API here, I mean an HTTP API or endpoint. So in this Shen API gateway, we try to replace some of the Erlang code and use Lua instead. So Erlang is then intended to, it's just used as the HTTP, and let's see if I can find it. So what we do in Shen is that we still keep this one here as the HTTP acceptor is still written in Erlang. It's the Cowboy web server. And then we have replaced these request handlers, so they're no longer written in Erlang. And instead they are using the Lua Erlang, which Robert talked about, to run Lua handlers. So the developer uploads a Lua script, a Lua handler, to the web server, which then will route the incoming requests to the Lua combination. Right, for each request that comes in here, each HTTP request, there is a new Erlang process that's being spawned. So this could be like you could have thousands of these request handlers running at the same time. And we actually do, so each request handler here is a Erlang process, and each process has its own Lua VM running the handler. Right, Lua for request handlers, and then we have an admin HTTP API for uploading and for doing this for publishing and creating and maintaining these HTTP endpoints. It's very simple. API, you need to be able to add a handler. You want to say that I want to add a new HTTP endpoint or API, say open chest. It should be called open chest, and when the HTTP request comes for opening a chest, it should run this Lua function. And you want to be able to update this handler, and you want to remove it, and you want to also be able to see which handlers that exist in the system today. Okay, another demo, just to show you how you can, well, actually, let's do it like that. So this is the, if we go back to this chest opening function, this is an example of a Lua request handler. So it needs to have this function signature. It needs to be named run, and it takes a user identification string as a argument. And we can use this UID then to actually call in. Here we are actually calling into the Erlang code. So we're calling Erlang code from the Lua code to get some user data that we need to determine what kind of icon we should give them. And again, here we are doing some, same thing, getting some other data from the Erlang, because we have a lot of data in the Erlang, on the Erlang side, that we need to access from Lua. And that's one of the reasons, well, actually that's the main reason why we choose to use the Lua Erlang instead of any other separate Lua VM, because we want to have this very tight integration with Erlang. So I can, so just to give you an idea of what it looks like, I can do the list. So here I have some command line interface there where now I can query the backend to see what kind of handlers do we have in this framework running right now. So we can see that we have two request handlers. We have some version information. We can see when it was last updated on the backend. It's active, and then we have something called AB group, which it's important for us to be able to do split testing. So when users in our system can belong to different split groups. So if you want to test functionality, you give one group a certain set of functions, and then the other group will have another set of functions. And in this Shen framework, you can associate a certain handler with a certain split group. So you can test, they have the same name, so you would have like the equip icon endpoint, but they have different AB groups, and depending on the users, which group the user belongs to, the different versions will be used. So if we just try to call, now this is just simulating a call from the client, an HTTP call using curl. So this is an unknown handler because, as you see from the list, it's not part of the system. So we can add it. Okay, actually give it the right name. And this OpenChest Lua, that's the same file that I showed you in the editor. And we can just list it again. And there we see we have a new function at version 1. And we can try to call it like this. And we get some result back. I'm not sure actually what that one does, but so what you saw there was that we added a new HTTP handler dynamically, and we can also remove it like that. So yeah, now it's not possible to call it anymore. is an unknown handler. So we did some benchmarking on this open chest function. So the top table shows the Lua implementation of the handler, and the bottom one shows the existing Erlang pure Erlang implementation of the same function. And as you can see, there's not a lot of difference. So this is using HTTP perf to measure the time it takes to make the HTTP request. And obviously I'm doing this on localhost. That's why we have 0.4 milliseconds for the HTTP requests. So you can see that at 1,000 requests per second, yeah, we get a max number of concurrent requests at 25, which means that we have 25 Lua VMs running concurrently on the back end, which is not a lot. We tested before with at least several hundreds, but no, several thousand, sorry. Actually, I couldn't get very interesting numbers because the load generator, HTTP perf, kept crashing on me. So, but you can basically see that the Lua implementation is seems to be 2 times slower, which is not much. It's a very simple function, though. So, but of course, the flexibility that you get by just dynamically being able to add new request handlers is worth a lot more than that. So the next steps, this is still a prototype for us. We don't run it in production today. We want to do that so we can speed up the future iterations. And it is a bit, we need to clean it up a bit, the code, and then we will open source it, put it on GitHub. We need some better way of handling session data, maintaining state across function calls. And monitoring, we need to have some kind of monitoring function, basically saying on average this has taken this much time to execute, and it has been executed this many times over the last X hours or so on. Debugging is priority 1, because today when you upload the handler, Lua handler, to the backend, you have no idea of knowing what is happening on the backend, because if you print something in the Lua script, it just goes to the logs on the server side, which is not very useful. You want it to come back to the client side. So we're going to override the print function, so it streams the data to the client, so you can on the client side subscribe to the print events, basically. We would also like to have the Swagger API generation, so that you can specify the HTTP API using the Swagger description language. This is what you do in the Amazon Gateway product. Yeah, change the name. Actually, I think I forgot that one. Oh, this one. The little guy here. That's Erlang Shen. That's why we called it the Gateway Shen. So it's a guy from the Chinese mythology. He had a crush on the moon goddess, and that's why we, Lua Erlang kind of shows the name Shen. Okay, thank you. Any questions? Yeah.
So in the diagram you have various.
Yeah.
Isn't that really used for SQL across
Yeah, you could use Redis. Yeah, we want to add a interface so you could basically access Redis from within the Lua handlers. Yes, but also we have another called, maybe you saw it on that diagram, Foundation DB. It's a NoSQL database that we also want to give access to from the Lua handlers. But that remains to be done. But it's very easy to do actually, so it shouldn't be a problem. Yeah, sure. Yeah. Yep.
What was the original reason to pick Erlang for writing web server in 2012?
We had some experience with Erlang before, and it just feels like the right choice if you're going to write this kind of network code or server type of code. Yeah.
And where do you validate the input parameters that you pass in the request, on the web server, or should you handle them in Lua?
Yeah, so that's done on the web server today. And that's also what we want to use this Swagger API generation. So we want to be able to generate the validation code from the description and then run it once the request comes in. Yeah. Yep.
Do you have any plan, or do you do some kind of sequencing, or running the code or the phrase, or being running Erlang means that you can isolate
So each one of these request handlers have their own Lua VM, and the Lua VM runs in a separate Erlang process, which is if it crashes, just that process is affected. So nothing else is affected, for example. Yeah. So it's like a sandbox. Yeah. Yep.
About the API gateway, you are not using Lambda behind it.
Sorry.
You are not using Lambda behind the API gateway.
No.
Have you considered?
That's the Amazon way to do it.
Yes.
Yes, it is. No, we actually started on this before we knew about it. But anyway, we don't want to be dependent on the Amazon stack. Yeah, because we don't run everything on Amazon. We use things like SoftLayer and DigitalOcean and stuff like that. So. Okay. Thank you.